Hello and welcome to the Unreal Numbers. In this video, we are going to talk about a very important topic of class 10 for ICSE and CBSE board, that is factor and remainder theorem. Here, I'm not making these videos to discuss everything in detail. I'll pick up those topics of class 10 and class 9, which are a little bit conceptual and they need an extra level of understanding. So let us start with today's class by understanding the division algorithm. So first of all, what is division algorithm for a number? Let's say I try to divide any number, for example, 33 by another number. Anything I can take. Let's say I want to divide it with 9. We know that 9 3s are 27 and when I subtract, I get 6. Here, this 6 is known as the remainder. 9 is called the divisor, 3 is known as the quotient, and that 33 is known as the dividend. The number which we divide is known as the dividend. Okay, so we can write this 33 as 9, that is the divisor, multiplied by 3, that is the quotient, plus 6. This is a rule that is followed by this dividend, divisor, remainder, and quotient. And it happens for any two number. For example, when you are trying to divide a number A, which is the dividend here, by a number B, which is the divisor here, you'll always get two numbers, unique numbers Q and R, such that they will satisfy this equation. A is equal to BQ plus R. But one thing to notice, and that is very important thing to notice, that this remainder is always less than the divisor. Because if you think that if I get anything equal to 9 or greater than 9, here, I would not stop. I would continue the division. I would do it one more time, right? Isn't it? So that means this remainder, when I stop dividing, when this number here is coming less than the divisor itself, okay? So therefore, here the relation satisfied by R, that it is always less than B. This is known as the division algorithm of the integers, okay? Now we'll talk about the division algorithm of polynomials. So first of all, let us consider a polynomial. Let's say Px is a polynomial. So we take a random example of a polynomial. Let's say Px is equal to 5x cube plus 3x square plus 8. And let's say I want to divide it with another polynomial, which is definitely like, first of all, if I ask you that what is the degree of this polynomial, you would say degree of this polynomial is 3. Why is that so? That is because the highest power of that polynomial, Px, is 3. And the highest power of any polynomial is known as its degree. So I'm considering this is our dividend. I'm considering another polynomial. Let's call it Qx. Let's not call it Qx. Let's call it Gx. And that is maybe, let's say, x square plus 3. Randomly, I have taken an example. So when I divide it using the long division method, which we all have learned in earlier classes, so I'll write this here in place of divisor, and 5x cube plus 3x square plus 8. So to do the long division, we know we have to match the leading term. Here the leading term is x square. Here the leading term is 5x cube. So to match the leading term, we can multiply this divisor with 5x. So multiplying the whole thing with 5x, we'll be getting 5x cube plus 15x. And we see that there is no x terms present here. So that 3x square will be coming down. As we subtract, 3x square will be coming down. Minus 15x will be there. And plus 8 will come. Okay. So now again, to match the leading term, we can multiply the whole divisor with 3. and that will give us a 3x square. But I'll get a 9 plus 9. So as we subtract, see, this 9 will be subtracted from 8. 15x will be coming as it is. So we'll get minus 15x and minus 1. Can I do the division one more time? I cannot. That is because the degree of this thing, this expression over here is 1, whereas the degree of this was 2. Okay, so when the remainder's degree, it is a polynomial, so it should have a degree. It's not a number that you can compare. It should have a degree. Okay, for numbers we compared whether it is greater or less. For polynomials you need to compare the degrees. Okay, degree of the divisor was 2, and this expression I'm getting the degree as 1. Whenever this happens, that the remainder polynomial's degree is less than the divisor polynomial, we stop the division. Okay, so that same idea, division algorithm for numbers, for integers, is applicable for polynomials as well. So what I'm trying to say here is that if you take any polynomial px, which is the dividend, and if you want to divide it with gx, which is the divisor, you would be getting a unique polynomial called qx, that is the quotient. Here it is 5x plus 3, and along with that you'll be getting a remainder, which is also a polynomial called rx. One very important thing again to notice here, that degree of the remainder, that is rx, should be less than the degree of the divisor, that is gx. Keeping that thing in mind, I want to show you one thing that will lead us to the first theorem that we are going to talk about, that is called the remainder theorem. Assume that if the polynomial, any polynomial px, is being divided with a linear polynomial, What does that mean? Linear polynomial means a polynomial of degree 1. Degree 1 means the highest power of x in that polynomial, of not x, of any variable in that polynomial is 1. So its form should be like, its general form should be like ax plus b, where a is not equal to 0. A is a non-zero term. So that is a linear polynomial. When any polynomial is divided by this kind of a thing, then try to understand px. Following that division algorithm, px would give you the divisor, that is ax plus b, into the qx plus some remainder rx. That's fine. We have understood up to this. Now, that condition that I have told you, that degree of the remainder, that is rx, should be less than the degree of the divisor. In this case, it is ax plus b. But we know degree of this thing is nothing but 1. Okay, the degree of this polynomial is 1. So degree of remainder polynomial should be less than 1. What is a number that is less than 1? What is an integer that is less than 1? I should say non-negative integer, because degree is a degree. We know that it is always a non-negative integer. What is it? It is a power, right? So polynomials powers in different terms should be a non-negative integer. We have studied that when we did polynomial, right? So degree of a polynomial is less than 1. So what are the possible case we are having? Degree of this rx must be 0. That is the only possible case. It cannot be anything else. Now, what is a polynomial having degree 0? It should not have any term, like any variable term which has degree more than 0. So it should look like some constant k, x to the power 0. That is the general form of a 0 degree polynomial. It is a 0 degree polynomial. Okay. So what is kx to the power 0? It's basically k. It's a constant. So any constant is actually known as a 0 degree polynomial. I'll just summarize the things I just said. Any polynomial px, when it is being divided by a linear polynomial, that is a polynomial of degree 1, its remainder should be a polynomial of degree 0, that is a constant. So if I rewrite the division algorithm for divisor being linear polynomial, I would get something like this. Px should give you the divisor, that is ax plus b, into the quotient polynomial, it could be anything, plus a constant. This is the main idea for the remainder theorem we are building. Okay. Now, what does remainder theorem say? Let's look at the statement of the remainder theorem, then I'll explain. Okay. So remainder theorem says that if a polynomial px of any degree, it could be of any degree, is divided by x minus a, try to understand x minus a, what is that? It is a special form of a linear polynomial. Okay, actually any linear polynomial can be expressed as x minus a. I'll show you how later. So this is a linear polynomial. A px is being divided by x minus a, then its remainder is pa. How it is coming? Let's go back to the previous concept that we have learned. We have learned by division algorithm, any polynomial px, when divided by a linear polynomial, that means divisor is x minus a, it should give you some quotient. We don't care what is it. It could be of any degree, definitely less than px, plus a constant. Okay. Now let's see what is the value of PA. They are saying that remainder is PA. Let's see what is PA. We know that in any polynomial, let's say you have a polynomial Px is equal to anything. Let's say ax square plus bx plus c. I'm just randomly considering like an example. Okay. So here in place of x, you put anything that x is substituted here as well. That is how a polynomial works. So if I substitute anything, I can substitute a number, I can substitute anything. I can, let's say I'm substituting a symbol, let's say star. So P of star will become A star square plus B into star plus C. Great. Okay. So if we substitute, we want to know the value of PA. If we substitute in place of X, if I substitute A, let's see what happens. This Px is represented by this expression. I don't know what is this Qx, whatever it is, it has a polynomial expression. Qx is also a polynomial, right? So it has a polynomial expression. Whatever there is, that X will be substituted by A. Okay. So let's see. Let's put in place of X, we put A. So PA is equal to A minus A. What did I say? X will be substituted with A. So this X has been substituted with A. So that becomes A minus A. QA, I don't know what is this Q polynomial because I'm doing it general. Whatever it is, its X will be substituted by A only, plus K. Now if you notice, this portion of the expression, what is this portion? This part gives you the part that is under inside bracket gives you a 0. And we know that 0 into anything, QA could be anything, I don't care. It should be 0. The whole thing will become 0. In that case, what is PA? Your PA is equal to K. What is this K? What is this K here? That was our remainder, correct? That was our remainder. Okay, so this is what the remainder theorem was saying. Can you read the statement one more time? If a polynomial Px is divided by x minus a, then the remainder is PA. I'll show you with one example. Randomly, I'd be considering a polynomial. Let's say that I take is equal to 3x square minus 23x plus 7. Great. I want to divide this with a polynomial x minus 7. Okay. So if I try to compare this thing, this is my divisor. If I try to compare this thing with the statement here, it says that if it is divided by x minus a. Okay. So comparing that, I can understand my a is 7. My a is 7. So according to the remainder theorem, my remainder should be P7. What is P7? I will substitute my value 7 in this polynomial in place of x. So it will become 3 into 7 square minus 23 into 7 plus 7. That is 3 into 49 minus 23 into 7 plus 7. What does that give us? 3 into 49 should be something around like 7 here, and 2, 3 4s are 12. We get 147 minus 23 into 7 gives us what? 23 into 7 will give us 21. 3 7 is 21. We get 2, and 14 and 2, 16, and plus 7. So doing the simplification here, we get 147. Let's do it here. Okay, so it gives us minus 7. Is that true? Let us verify that. Okay, let us actually divide and see if we are getting minus 7 as the remainder. So what I'm going to do is I'll divide 3x square minus 23x plus 7 by that divisor that I have, x minus 7. And now we all know if we want to match the leading term, it will become 3x. I will be taking 3x, so that will give us a 3x square, and minus 21x. Changing the signs here, this would become minus, this will become plus. 3x square would be cancelled. I'll be getting a minus 2x from here, and 7 plus 7 will come up. So to match the leading term again, I need to multiply with a minus 2, and that will give us a minus 2x plus 14. Changing the sign, this will become minus 14 over here. 2x cancels, and I get minus 7 as my remainder. And I have to stop the division here because degree of this thing, what is the degree of this thing? This is a 0-degree polynomial, we know, is now less than degree of the divisor we started with. It was a 1-degree polynomial. And you see that without dividing, just by using the remainder theorem, we are getting the remainder. That is the use of remainder theorem. Okay, I hope you understood this. Now, going into the factor theorem, which is basically a special case of the remainder theorem itself. So what they're saying, if a polynomial px is divided by x minus a, same thing, no change, okay? No change from the remainder theorem. Its remainder is pa. That was the statement of remainder theorem. Now they are saying, if pa is equal to 0, if pa is equal to 0, that means the remainder is 0. What was pa? Pa was remainder by remainder theorem. So that means the remainder is 0. Then x minus a is called a factor of px. What is a factor? Let's revise it one more time with numbers. For example, you are dividing 12 by 4. We know 4 3s are 12. Division is complete. There is no remainder. Whenever a number leaves no remainder while dividing another number, we call it a factor. 4 is a factor of what? Of 12. 4 is a factor of 12. Similarly, if a polynomial, any polynomial gx divides px and leaves no remainder, then gx is a factor of px. Simple thing. Okay, same as numbers. Simple, clear-cut understanding here. Okay. So that is what they are saying, that if somehow that PA, while substituting, you are substituting A in place of the polynomial, if you get that answer as 0, that means your remainder is 0. That means the divisor polynomial, that x minus a thing, was a factor of the dividend polynomial, that is Px. I hope you understood this. Let me show you with an example. Let's say that Px is equal to x cube minus x square plus x minus 1. And I want to divide it with a linear polynomial gx called x minus 1. I'll divide it with x minus 1. Let's divide. So let's simply use the factor theorem. It says that, acha, can you compare the gx with this term here, x minus a, and can you tell me what is your a here? Your a is 1. Achha, how I am getting this? This is a very, this can be sometime very tricky. So the basic idea, this is just a bonus trick that I'm giving you, that to determine this a, whatever that gx is given, equate it to 0. That means x minus 1 was given, right? X minus 1 equal to 0. X will come as 1. Whatever x's value is, that is your a. That is how you determine a. So this is your a equal to 1. Let's see what is P1 coming. P1's value is 1 cube minus 1 square plus 1 minus 1. What is that? 1 cube is 1 minus 1 plus 1 minus 1. And that is 0. That means if we divide x minus 1, if we divide, this x cube minus x square plus x minus 1 with x minus 1, it would leave no remainder. That means x minus 1 can completely divide that polynomial. If we divide, let's see what we get. X cube minus x square plus x minus 1, dividing it by x minus 1. First, to match the leading term, we get to multiply with x square. So this gives us x cube minus x square. Both the terms are getting cancelled. So we get it minus and plus. Both of them are getting cancelled. We get here x minus 1. So that just we need to multiply with 1. We get the same thing and the division is complete. So the quotient coming here is x square plus 1. That means x cube minus x square plus x minus 1 is nothing but x minus 1 into x square plus 1. These are the two factors of the given polynomial, and it is now completely factorized. In ICSE, you will get the questions that prove that this is a factor and now completely factorized. I'll show you in the next part of the video. I'm going to show you some examples from the PYQ questions, and second part. Okay, so the first question that we see is a question from ICSE 2018. It says that if x plus 2, x plus 3 are two factors of this polynomial x cube plus ax plus b, then find the values of a and b. So it's very easy. We consider the polynomial, given polynomial px as px. This is x cube plus ax plus b. Fine. So this is a factor. This is also a factor. So let us consider those factors as gx, that is x plus 2, and hx is equal to x plus 3. What does it mean by their factor? That means if I divide px with gx, I would be getting 0 as remainder. Or using factor theorem, what is, if I compare with that x minus a, you can understand your a is going to be minus 2. So by factor theorem, p of minus 2 should come as 0. Substituting in p's expression, we'll be getting minus 2 cube plus a into minus 2 plus b is equal to 0. Simplifying that, we will be getting minus 8 minus 2a plus b is equal to 0. And that gives you minus 2a plus b is equal to 8. Let's keep it. We will deal with it later. Let us look at the other condition given. Hx is also a factor of px. So comparing that hx with x minus a, we know how to compare. We will just simply equate x minus 3 is equal to 0. X plus 3 is equal to 0. So x is equal to minus 3. Now we know that x's value is a's value is minus 3. So using factor theorem, p of minus 3 must be equal to 0 because it is given that x plus 3 is a factor. So substituting that value over here, we get minus 3 whole cube plus a into minus 3 plus b equal to 0. And we get minus 27 minus 3a plus b equal to 0. So that give you another equation, minus 3a plus b equal to 27. Solving these two equations, we will get our values of a and b. I leave that part on you as your homework, and you have to comment the answer, the values of a and b in the comment section of this video. Okay, so that is the task for you. Now we move on to the next question. This is another question from ICSE 2018. Remember, I was saying that use remainder theorem and factorize the polynomial. Okay, so I was saying this kind of questions they usually ask. So first of all, we need to use remainder theorem. How do you use remainder theorem? We need to guess. Just by hit and trial method, we need to find out at least one factor for this polynomial. First of all, we consider this polynomial as px. So our px is equal to 2x cubed plus 3x square minus 9x minus 10. So we will put different values of x and we will see when it is giving you 0. When it is giving you 0. Okay. So usually the x's value is very small. This kind of question they ask, usually the x's value is very small, like minus 1, plus 1, minus 2, plus 2. Within that, you will get your value. Okay, if you are not very unlucky. So I'll try with I'll try with plus 1 at first. Let's see what happens. P of 1 is 2 into 1 cube plus 3 into 1 square minus 9 minus 10. What is it coming? 2 plus 3 minus 9 minus 10. That is 5 minus 19. Definitely not equal to 0. So that means 1 does not work. What does it mean? X equal to 1 does not work. That is x minus 1 is not a factor. Not a factor. Great. So what is a factor then? Let us try with 2 maybe. Let's see what is P2 coming. P2, I'll be just doing it directly. P2 will come as 20. It's 8 into 2, that is 16. Should come as 16. And then 2 square is 4, that is 12 minus 18 minus 10. Is it matching? Let's see. 16 plus 12 is 28. And this is minus 20 coming as 0. So you get one factor. What is that factor? X equal to 2. That means x minus 2 must be a factor. So if x minus 2 is a factor, now we can get the other factors by simply dividing the given polynomial by x minus 2. So as we get P2 is equal to 0, we need to clearly mention, therefore, by, they have said remainder theorem, but it should be factor theorem actually, okay? So by factored theorem, x minus 2 is a factor of dx. To get the other factors, we now divide. So let's see. The polynomial given was 2x cubed plus 3x square minus 9x minus 10. We divided with x minus 2. So to match the leading term, we all know we need to multiply with 2x square, and that would give us a 2x cubed and minus 4x square. Changing the signs. These are very simple things. I'm not going to explain. We'll be getting 7x square and minus 9x minus 10 will come. So now again matching the leading term, we get to multiply with 7x. That gives us something like 7x square and minus 14x. So cancel this, make it plus, should become 5x minus 10. Great. It will be 5 now, and that will become 5x minus 10, and this should cancel. This will be completely subtracted. So the other factor is 2x square plus 7x plus 5. So your Pax, whatever that polynomial was given, this polynomial can be written, one of the factor is x minus 2. That is great. Other factor must be 2x square plus 7x plus 5. But you need to check, is it completely factorized? For that, you need to try to factorize, at least try to factorize that polynomial, maybe with middle term method. Usually middle term method will work here. You don't have to do like quadratic equation and all, quadratic formula and all. Usually, if it is factorizable, you will get it using middle term method. So let us check it once. It becomes 10. Can I break 10 so that I get 7 as the sum of the factors? Yes, I can get 2 and 5. So you can write it as x minus 2, 2x square plus 5x plus 2x plus 5. Keep x minus 2 as it is. You can take a x common. That'll give you a 2x plus 5. And then you can get a plus 1 common. That will give you a 2x plus 5 again. So x minus 2, you get a x plus 1 and 2x plus 5. Notice that this was a degree 3 polynomial, and here also we are getting product of 3 linear polynomials. So this is now completely factorized. Sometimes it may happen that this quadratic is not factorizable. So then in that case, you need to keep it as it is. So I hope this is clear. We move on to the next question now. Okay, from ICSE 2019, it says that find the remainders obtained when this polynomial x cube should be plus here, I think, plus kx plus 8x plus k is divided by x plus 1 and x minus 2. I'll just give you a hint for this problem because we have already done one of such problems previously. So what I'll do, actually what you will do, you will take px as the given polynomial, that is x cube plus kx plus 8 into x again plus k. Maybe you can simplify this a little bit. You can write it as x cube plus kx square plus 8x plus k. So here we'll be getting p of minus 1 is equal to, it's coming minus 1. I'm doing it directly. Minus 1 cube is minus 1 plus k, because minus 1 square is just plus 1, minus 8 plus k, 2k minus 9. Have we done it correct? Minus 1 plus k minus 8 plus k. Yeah, that is coming as 2k minus 9. So this is your first answer. What is the remainder when you divide with x plus 1? 2k minus 9. What is the remainder when you divide with x minus 2? That should be P2 by remainder theorem, because if you compare x plus x minus 2 equal to 0, it will give you x equal to 2. So your P2 is coming, should be 8 plus 4k plus 16 plus k. That gives you 5k plus 24. Now, so these are the answers for the first two parts. Now they are saying find the value of k if the sum of these two remainders is 1. So that means sum of this value and this value is equal to 1. So it's very simple. 2k minus 9 plus 5k plus 24 is equal to 1. Solve this equation and get the value of k, and you know what you have to do. Write the answer in the comment section. Okay. Moving on to the next question. Okay, great question. It says that what must be added with this thing so that it leaves a remainder 10 when divided by 2x plus 1. Okay, fine, fantastic. So let's take it as px 2x cube minus 3x square minus 8x. What must be added with this thing so that it leaves a remainder 10 when it is divided by 2x plus 1? I don't know what must be added, so I should assume it. Let's say I assume k must be added. K must be added. I will get the value of k. That is my job. Okay. K must be added. Great. So then your polynomial will become, like the px thing will become this plus k. Actually, you should consider px as that given polynomial plus k. Okay. So k must be added. We have assumed. This is your divisor polynomial. 2x plus 1 is your divisor polynomial. So what is your a? This is very important to understand. What is your a here? If you try to compare this thing with x minus a, what is your a? Simple. Concept is same. 2x plus 1 is equal to 0. From here you get x is equal to minus half. Fine. So minus half should be replaced in place of x in px. So p of minus half should be equal to 10 because they have said remainder is 10. So what is p of minus half coming? Let's check. 2 into minus 1 by 8. I'm doing it directly. Minus 1 by 2 cube is minus 1 by 8. Let's write it here. Minus 1 by 8 minus 3 into 1 by 4, because negative number square is positive, minus 8 into minus 1 by 2 plus k equal to 0. Just simplifying that, we'll be getting minus 1 by 4 minus 3 by 4. Minus minus, it becomes plus 4 plus k equal to 0. Solving this, I think here you'll get a minus 1 plus 4 plus k equal to 0. This will imply, is this coming minus 1? Yeah, this is coming minus 1. You're right. So that is 3, and 3 goes to the other side. This becomes minus 3. Oh, why have I written 0? Sorry, my bad. It should be 10 here. So 10 minus 3 should be equal to 7. So 7 must be added with the given polynomial so that it leaves a remainder 10 when it is divided by 2x plus 1. So I just need to tell you one thing, that if you need a personal guidance in ICSE class 10 or any other boards, it may be state board, CBSE board, as I'll not be able to discuss all of the topics in YouTube. So you can contact me. The number is given. You can talk about the personal live classes. There is a batch. There are one-to-one classes. You can contact the unreal numbers, and the best of the classes will be based of the experience that we'll be getting from our live classes. That I can assure you. Thank you for joining. I'll be coming up with more and more such videos. Please keep supporting. Please subscribe to my channel. Thank you.